continue curve sketching. This is example 2. The function is a polynomial, degree 4. Well, to sketch this curve, anything we can say about this function? This function is not even, not ordered, not periodic, and that function covers from minus infinitive to positive infinitive. Therefore, the domain is all real numbers, and so is the range. So we just start find try to grasp some points which is helpful for us to sketch the curve. Now here, don't you think we can find the y-intercept? Right, this one is x cubed, x plus 4, right? Therefore, y equal to 0, no. Y equal to, yes, y equal to 0, x equal to minus 4, right? So this is my x-intercept. Y-intercept, of course, x equal to 0. And goes to 0. This point might be useful for a sketch curve. Then otherwise that we find a derivative, right? The reason doing derivatives is because we try to find the maximum, minimum, increasing, decreasing these things. 4x cubed minus plus 12x squared, right? So this is a 4x squared and x plus 1, isn't it? No, plus 3, right? All right, good. And the first derivative equal to 0 means that x equal to 0, x equal to minus 3, right? So these are 2 points we should discuss. Then the second derivative, which is equal to 12x squared plus 24x, and by simplifying it into factors, there's 12x x plus 2. So when the second derivative equal to 0, which means that x equal to 0, or x equal to minus 2. So these are points might be useful for us to discuss in terms of sketching in order to sketch the curve. All right. So, is there any other points we should discuss? No. So we have 3 points, right? So let's draw the sketch, draw a table. Which, how many points? 1, 2, 3. First point is minus 3, then minus 2, then 0. This is x from minus infinity to minus 3, minus 3 to minus 2, minus 3, minus 2 to 0, and from 0 to infinity. All right, good. Then y derivative, then the second derivative, then y. Okay. To find the sign for the first derivative in this interval, we choose a number, say minus 4. Minus 4 we choose minus 4 here. Minus 4, this is always square or positive, therefore minus 4 plus 3 is negative. This is negative. Minus 3 is 0. Here I choose minus 2.5. Minus 2.5 is positive. Here, positive. Here I choose minus 1. Minus 1 put here is plus. 0 is 0. Infinity is okay. Second derivative. This is second derivative. In this interval, I choose minus 4. Minus 4. This is minus. This minus is plus. Minus 3. Minus 3. Minus 1 is plus. Right? This one, I choose minus 2.5. Minus 2.5. This is negative. This is negative. So it's plus. Yeah. Minus 2 is 0. And here I choose minus 1. Minus 1 is minus. And here, 0. Here, choose million. Okay. Now then I use my second derivative positive. First derivative negative, so this is the shape. This is the shape of curve. And the positive is this is the shape. Negative, positive. Negative, positive is this shape. Positive, 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 so this is the shape. No. Correct? Negative, positive. Well, if you have some problem in connecting these curves, then it somewhere might be miscalculated. Somewhere it must be wrong. Let's check this one. Minus 1. Minus 1 to first derivative of this one. Minus 1 is positive. This is positive. This is positive. This therefore is positive. It's correct. Second. That's right. Well, okay. This is right. Well, here, something wrong here. This from minus 2 to, because after minus 2 there's a no more critical point. So this 0 should be this minus 2. Wait a minute. This has a problem here. Minus 2 minus 2 zeros. I choose minus 1. Minus 1 here is plus. This one minus 1 is minus. Minus is not this shape, right? Minus is not shape. Sorry. I knew something is wrong. Minus this, positive. I put this side. Sorry, I should turn to this way. This is minus. Minus is umbrella. So positive, this shape. Yeah. And the positive, this is the way, right? Positive, positive, this is the shape. Now it's correct. All right, everything is corrected. Then we need this point, right? We need this point, f of a minus 3. F of a minus 3 is this. This is plus 1 is 27, right? Minus 27. By plugging minus 3 to this function, right? And then minus 2, by plugging minus 2 to this function, this is 2. This is 8. 2 times 8, 16, right? 16, yeah. Minus 16. And plug a 0 here. F of a 0 is 0. This is 0. This is minus 16. And this is minus 27. And obviously this is a minimum. Obviously this is a point inflection. Right? Change it, increase it this way and increase it that way. And this point inflection. And here, increasing and increasing again, but different way of increasing this. This is point inflection. This is point inflection. Okay. Then we can join pictures nicely. This is y, this is x, this is 0. And let's plug some important points, minus 3, minus 2. This is minus 2, right? Minus 2, this is minus 3. Minus 3. This is minus 27. This is 20 is here. Minus 20. Minus 10. 16 is here. Minus 16 here, right? 16 here. This is a sketch, I mean, roughly this is the situation. And we have a point x intercept is minus 4. So minus 4 is here. 2, 3, 4. 4 is minus 4 is here. Okay. So all the points are set. X intercepts, minimum, point inflection, point inflection. So finally we can join these things. From infinity to this point, 3 minus 10 is this shape. Through this, right? Through this. So it has to be through x intercept. It's not easy to draw to have a nice curve. From infinity to this point, minus 3, minus 27, in this shape. And the gradient is 0. The gradient tangent is 0. It has to be horizontal tangent line. Then go to this point in this shape. This shape goes this way. Then from this point, minus 2, minus 16 to 0, 0, 0, 0, this point, right? Using this shape, and this is the way, right? Now, be careful. If you draw the curve like this, it might be wrong. Why? Because the gradient tangent line to the curve at this point 0 is not 0. But here is 0. Is 0. So this has to be horizontal tangent line. Horizontal tangent line. I did just a little exaggerate. So the horizontal, okay? Then after that is this shape. And be careful that the gradient tangent line is 0. It's horizontal. Yeah, so it has to be very smoothly drawn. Smoothly. This is the point inflection. This is a point inflection. But horizontal tangent line cutting through this point. Very nice curve. Very nice curve.